Well, hello students. Today we're going to learn about an important part of trigonometry that you're going to have to do a little bit of memorization. This is going to carry over to Math 3 as well, so this is something you really do want to try to lock down. At first it's going to seem complicated, but as we practice it, I think you'll see that other than memorizing a couple of relationships, it's not that big a deal. Anyhow, the topic is what we call in mathematics special right triangles. And there are two types. There's the 45, 90, and then you have the 30, 60, 90 triangles. Now I would hope that you would be copying this down. Certainly you can come back and watch the video again. And in a few minutes I'm going to show you how to work through the worksheets. Be best if you can print them out. Not everybody can, I realize that, but if you cannot print them out, at least do the answers on plain paper, take a photo of it and submit it to me through Canvas. All right, the 45, 45, 90 triangle looks like that. It's an isosceles triangle, which means then that the two legs are always going to be congruent. Now, in a 45, 45, 90 triangle, the sides work this way. If this side we call x length, then this side is going to be x length, and this side is going to be x length times the square root of 2. Alrighty? Now, let's go over here to the 30, 60, 90. The 30, 60, 90 triangle looks this way. The side across from the 30-degree angle, that's the key side. The side across from the 60-degree angle is going to be that length times the square root of 3. And then the side across from the 90, or in other words, the hypotenuse, is going to be that length times the number 2. Now, guys, notice the difference. With the 30, 60, 90, it's the x times the number 2. With the 45, 45, 90, it's x times the square root of 2. You don't want to get those two confused. Now, let's do a couple examples right here. Let's say that this side length was 5 units. Well, how long would this one be? Well, that would be 5 units long too. And how long would the hypotenuse be? Well, that would be 5 times the square root of 2. So that length, and that length. Over here, let's say this length was 3 inches. Well, what's this length going to be? Well, it's the side across from the 60. So it's 3 inches times the square root of 3. And this would be 3 times 2, or in other words, 6 inches. That's not 61, that's 6 inches. All right, let me erase those and let's try a couple more here. It's kind of a weird eraser. All right, let's say now that this length, we're told, is 10 inches. Now, it's a 45, 45, 90. We need to find out what these sides are, and if we find one, obviously it's the same for the other. So what we're going to say is, well, 10 inches is the same as x times the square root of 2. So what you're going to do is you're going to say x times the square root of 2 is equal to 10. And then we're going to divide both sides by the square root of 2. Those cross out, and so we have x is equal to 10 times divided by the square root of 2. But we have to rationalize that denominator. So we're going to multiply top and bottom by the square root of 2. And so here we have 10 square roots of 2 over square root of 2 times square root of 2 is the square root of 4. What's the square root of 4? It's the number 2. And then we notice that that 10 divides by 2. And so we have x is equal to 5 times the square root of 2. All right, so then we're ready to write our answer. This is 5 times the square root of 2, and that length is 5 times the square root of 2. Now, if you wanted to check, let's work backwards. Let's say we know that the length is 5 square roots of 2, and we know times the square root of 2 would equal this hypotenuse. Well, square root of 2 times square root of 2 is the square root of 4. And what's the square root of 4? Well, it's the number 2. So you have 5 times 2 is equal to the hypotenuse. Or in other words, the hypotenuse was 10, and that's what we started with. Okay, let's come over here and do a similar one. Let's say that we're told, well, in fact, let's do the same one. Let's say that we know that the hypotenuse is equal to 10, but we don't know those other sides. Well, we know that that 10 came about because you multiplied some number times 2 and you got 10. Well, what number did you multiply by 2 to get 10? Well, in this case, it's easy to figure out. That was 5. Well, then the side across from the 60 is going to be what? Well, it's going to be 5 times the square root of 3. Like so. Okay, now let's go look at the worksheet. The only problem with this worksheet, it's in a PDF and I cannot write on it. It doesn't work with this particular smartboard. But we'll talk through it together, and maybe that will help. Let me get a sip of my coffee. All right, so let's see, which one is this? This is the one 45, 45, 90. There are two worksheets, 45, 45, 90, 30, 60, 90. Let's do the 45, 45, 90 first. Okay, you've got to keep in mind, in fact, let me go back here and let's see, let's add a new page. Again, you've simply got to remember these relationships. If that's 45, then that's got to be 45, and this is x times, and that one is x, and this is x times the square root of 2. These have to be memorized. And then the 30, 60, 90. The side across from this 30 is always going to be the x. Let me stay there for a minute. The side across from the 60 is always going to be x times the square root of 3. And the hypotenuse is always going to be x times not the square root of 2, but in this case, the number 2. Now, those have to be committed to memory. I don't know a slick way to memorize them. You just write them down on blank paper until you figured out how to do it all. All right, so we may be coming back to that. Let's go back here. So here we asked BC. How long is it from B to C? Well, if this is a 45, 45, 90, right? Well, I don't know what happened there. That's cool. Let's see if something writes here. No, it doesn't. I don't know what that did. All right, well, never mind. Anyhow, if this length is 5, that length has got to be 5. And what is this length, A to C? It's 5 times the square root of 2. So you'd put that down here. Notice they tell you it's whatever that length is times the square root of 2. Similarly, over here, number 2. From P to Q and Q to R, well, we don't know how far they are. But we know this is a 45, 45, 90. The hypotenuse is 3 times the square root of 2. So that must mean then this length is 3 and that length is 3, because remember, it's whatever this side is times the square root of 2. All right, so you can complete those. Let's see here. They're all, really, there's nothing any more problematic there. Let's go to number 7. Notice that this, what is this thing? A roller coaster. That's a 45. So if that's 45 and we assume that's a 90, that's got to be a 45. So if this is 100 feet here, that guy's got to be 100 feet. And this length would be 100 feet times square root of 2. All right, a square has a perimeter, okay, of 32 inches. All right, a square has a perimeter, that's all the way around. So what's 32 divided by 4? I don't know, what, 8? Okay, so let me go back over here. In fact, let me add a third page. If you've got 32 inches all the way around in a square, and you know that each side is 8, well, how long would that diagonal be? Well, hopefully you can picture that if that's a 90-degree angle, then half of that's 45. So, in other words, we've got a 45, 45, 90. If that side is 8, then this side is going to be 8 times the square root of 2. All right, let's see what else we got here. All right, so the rest of that y'all can do. Let me now go to that other worksheet. And let's make this thing bigger. All right, similar worksheet. If A is 2, then the easiest one is that the hypotenuse, since that's the side across from the 30, and that's 2, the hypotenuse will be 2 times 2, or in other words, 4, okay? The side across from the 60 is always one, so a little more squirrely, but we know that it's this length times the square root of 3. So the side across from the 60, or in other words, B, will be 2 times the square root of 3. And you'll complete these similarly. Ones like number 6 is going to be a little more difficult because you start off with C. Well, if C is 20, what's A? Well, A has to be half of 20 because it's A times some number gets you 20. So that's 10. And then this side would be 10 square roots of 3. All right, now you don't forget to rationalize the denominator. I'm trying to think, these all kind of work the same. And let's just pick out one here real quick. I'll try to do a hard one. Well, none of them seem to be too hard. All right, let's do 33. This will be as hard as it gets. I don't know if y'all can see that. All right, so we're told that the side across from the 60 is 8. In fact, let me try this on a separate thing. So if that's 60, this has got to be the 30. And we're told that the side across from the 30 is 8. And I forget what were the other dimensions. We're looking for A and C. Okay, well, we know that the side across from the 60 is this number times the square root of 3, right? So let's write it over here. We know that side A times the square root of 3 got us that side across from the 60. So we're going to divide both sides by the square root of 3. Once more, we have to rationalize that denominator. Square root of 3 times the square root of 3. And so we have 8 times the square root of 3. Square root of 3 times square root of 3 is the square root of 9. The square root of 9 is the number 3. All right, so as strange as that looks, that is side A. So 8 square roots of 3 over 3. That's side A. This was side B. That's what we started with. Now, how do we get side C? Well, remember, the hypotenuse is 2 times whatever that is. So 2, and since it's a fraction, let's put it 2 over 1. And again, remember you multiply side by side. So 2 times 8 is 16 square roots of 3 over the number 3. Now, at this point, if 16 divided evenly by 3, you would do that, but it doesn't, so we're going to leave it be. So that should help you to get both sheets done and submitted to me. And y'all have a great day, and I'll be glad to see you whenever I do. Bye-bye, y'all.